So for today's class, we're going to be going to review how to factor quadratic equations, or just factoring trinomials that you've learned in grade 10. So for example, you're given x squared plus 7x plus 12. And you're asked to factor them into two brackets. So you should have something like this in the end. Sounds familiar? So what you're going to do is, the trick is you put a little cross like such. And you're trying to think of two numbers such that when they multiply each other, they will get you 12. And when you add those two numbers, it gives you a positive 7. And how do I get those numbers? It's this one right here and this positive 7 right here. And so if I continue, what two numbers multiply to get 12? Well, it's 3 and 4. And when I add them, they also give me 7. And you can tell that the only way to get 7 is both of the numbers have to be positive. Or, actually, that is the only case. So once I know that 3 and 4 are my combination, then I just rewrite this quadratic expression. I split the 7x into 3x plus 4x, and I write everything the same. And afterwards, I'm just going to use a different pen, and I'm going to group them. It doesn't matter which one you pick. If you happen to write 4x in front first, that's totally fine. It just should still get you the same answer in the end. So after I put a bracket down, then I look inside each of the bracket or parentheses and see which one I can factor out. So x squared plus 3x, what do they have in common that I can factor out? Answer is x. So I'm going to factor an x out. That means I divide each term by x. So I get back x plus 3. And I do the same thing for the other bracket. This is add, so I still remain the same thing. And I factor out a 4. So once I divide each term by 4, I get x plus 3. Now you can see that, I'm going to underline again, technically this and this also have in common between the two terms. So I can actually factor x plus 3 out. Same thing. So if I factor out x plus 3, what do I get back? I divide each of the term by x plus 3, and I will get x plus 4. And so therefore, you can see that we have factored x squared plus 7x plus 12 into x plus 3 times x plus 4. And we call this factoring. Okay, and you may ask, well, what happens if I want to do something else or something different? Then we're going to do something different right away. What if the coefficient in front of x squared is not 1, but a different number? For example, 2. Instead of x, let's just put a different variable, n squared minus 3n minus 14. And you can see that the number in front of the n squared term is not 1 anymore. It's actually a little bit harder to do now, but the idea still stays the same. You make a cross as such, and you think of two numbers, when they multiply, will get you 2 times negative 14, which is negative 28. And what two numbers, when you add them together, would give you negative 3. So the negative 3 still stays, and the top number, negative 28, is by multiplying the a and the c of the standard form of the quadratic equation. So those two numbers are 7 and 4. Well, you know that 7 and 4 gives you 28, but one of the numbers must be negative. And so you look at the negative 3. When you add those two numbers, it gives you a negative 3. That means the bigger number, which is negative 7, well, the 7 must be negative in order to produce a negative 3. So I got my combination. Then I did exactly the same thing as the previous question. So I write down everything. I split the 3n into minus 7n plus 4n minus 14. And after I did that, I did exactly the same thing as I did before. I grouped them as such with two brackets. And then I factor out within each of the brackets. So the first one, 2 and 7, I can't factor out, but n I can. So I factor out an n. I would get back 2n minus 7 plus the other bracket, I can factor a 2 out. So I factor out 2. What's left inside is 2n minus 7. As you can see, exactly like the previous question, 2n minus 7, you can factor it out. So once I factor out 2n minus 7, what do I get back inside is n plus 2. So you see, using the exact same method, this one right here, as long as you find the combination, then you can always factor regardless of what is the number for the coefficient in front of the squared variable.